Okay, so you've come here for the shortcut method for doing a secondary port calculation. And that's a great idea. If you can wrap your head around the mathematical method, it's not too difficult. What we do is we look at, for example, 10A from the exercise book. This looks at the same crocodile that I've drawn out there for you. And high water time is given as 15:02 in the standard port. And the adjustments go from 12 o'clock to 6 o'clock. So 15:02 is 3 hours and 2 minutes along the way. 3 hours, 60, 120, 180. So we've got 182 minutes. 6 hours, 360. We've got 182 360ths. That's from there to there. So 182 is there, out of a total of 360. Top line then, we've got minus 42 to minus 17, and that is an interval of 25 minutes. So we were 182 360ths of the way through that 25-minute interval, and that 25-minute interval starts down there at minus 42. So we're going to add that to minus 42. The calculation is going to be 182 360ths of 25 added on to 42 there. So you'll put that into your calculator, and your calculator is going to spit out minus 29.3611 recurring, which, so long as it's below 29.5, we're going to round down to minus 29 minutes to the nearest minute. Can we do the same thing with the heights of high water and low water? Yes, we can. And in the example 10A from the Yachtmaster exercises, the high water height happened to fall exactly on one of the adjustment numbers, so we didn't have to draw a crocodile or interpolate. But low water was different. Low water was 0.7. 0.7 lies somewhere between 0.4 and 1.1. Specifically, it is 0.3 of the way along the line between 0.4 and 1.1. That line is 0.7 long, so we're 0.3 0.7ths, if you like. So you can think of this line going all the way here, 0.7, we're 0.3 0.7ths, the same as 3/7. We'll call it 0.3 0.7ths of the interval along the top, which in this case is 0.4. It starts from 0. So we're going to add our 0.3 0.7ths of 0.4 to 0 in the calculator then. Again, that's going to spit out 0.171428, and we're going to round that to the nearest 0.1, which is an adjustment of plus 0.2. So it really is quicker once we get the hang of these mathematical tricks. We can save ourselves quite a bit of time. Let's have a look at 10B then. So we've sketched out the triangle perhaps, or written down a few numbers so that we can check our workings. It is possible to make a mistake using this method if you're not careful. So we find our high water time, 16:02. We have a look at our adjustment table, and we see that 16:02 lies between 12 o'clock and 1800. Specifically then, it's 4 hours and 2 minutes, which is 242 minutes out of those 6 hours, which are 360 minutes. So that's 242 360ths. Now the interval between minus 40 and minus 18 is 22 minutes. So we're 242 360ths of the interval of 22 minutes. Now it starts from minus 40 on that left-hand edge. So we're going to add that fraction to minus 40. That fraction being 242 divided by 360 multiplied by 22. You put that into your calculator and subtract 40, or put it in the memory and add it to minus 40 if you just want to be careful. It will come out the same way as minus 25.2, which is closest to minus 25 minutes, to the nearest minute. Then we go ahead and we do the same thing for the high water height of 3.5 meters. High water 3.5 meters is somewhere between 3.4 meters and 4 meters. So the interval there is 0.6, and we are 0.1 0.6 along the bottom line, a sixth if you will. The upper interval goes from 0.3 to 0.7, which is 0.4 long. The interval is 0.4. So we're going to take a sixth of 1.4 there. Sorry, I'll say that again, a sixth of 0.4. We're going to take a sixth of 0.4. And that sixth of 0.4, we're going to add to the left-hand starting point of 0.3. So it's 1/6 of 0.4 added to 0.3, which your calculator will give you a 0.3666 recurring. And we're going to round that up to 0.4 to the nearest 0.1. We'll do the same thing for the low water height. Low water height is 1 meter. 1 meter is between 0.4 and 1.1 meters. So the interval on the bottom line is 0.7, and the interval on the top there is 0.5. So we are 0.6, 0.7 along the way between 0.2 and 0.7, which is 0.5. So if we do 6/7 of 0.5 and add that to 0.2, we will get our adjustment time, our answer. Calculator gives us 0.623, and we'll round that to the nearest 0.1, 0.6 meters, which we'll add to our low water height. So that's going to give us a low water height of 1.6 when we go back to do the sums. So see the other videos. This is just for working out the adjustment heights quickly using a mathematical method. Do please go and check how this whole process fits together in the other videos. If we looked at certain places in the world, you'll find the adjustment times, so in Tingwall here, are quite substantial. This one here, -0.200, and what they are implying there is that is 2 hours earlier in Tingwall than it is in Kirkwall, and not 200 minutes. So 0200 is 2 hours, not 200 minutes. And that's all you need to know then to get these crocodiles out of your life, and just get on and quickly calculate all your secondary port adjustments and save yourself a lot of drawing and a lot of time. Best of luck.